Alright. Welcome back to Big Caleb's Math and Mayhem. Tonight we're going to be doing another statics review problem before we really get into, main gist of mechanics of materials. Alright. Let's go ahead and draw our free body diagram. Then I'm going to tell you what we're trying to find. So how is y'all statics and materials, or mechanics and materials class going right now? For me, it's going well. I think I need to study just a little bit more. Of course, that's kind of what these videos are about, so I think anything kind of helps. I don't know where y'all are at, but it's a little late where I'm at right now. And I am tired. I just turned in my engineering analysis homework for the week. And, well, let's just say, hope that it works. Alright, good deal. Alright, so we have a pen. Let's see. It's another important thing we discussed in the last video. And we have a roller at A. Now, this right here is called a distributed load. In statics, they taught you a way to solve this. I am also going to teach you the way to solve this. Okay, so let's draw another picture over here. And it's going to represent from, I believe, B to C. Yeah, okay. Okay. So let's draw our little distributed load. It's the same one as over here. Okay. So, what we need to do is right here we have 5 meters, and right here it says 5 kilometers per meter. This is very simple. We just go 5 meters times 5 kilometers over meters, which cancels out the meters, leaving you with, oh, sorry, that's kilonewtons. Leaving you with 25 kilonewtons. So, you can actually say this force is now 25 kilonewtons. Okay, good deal. Alright, I'm also going to go ahead and define a few other things while here. Alright, because it's a roller, we're only taking the forces in the AY direction, just like last time. I'm going to define a little bit more distance right here, where the 25 kilonewtons goes down. So between that, it's going to be 2.5 meters on both sides. They'll become important a little bit later when we take a moment. Okay, over here at point C, it's a pin. We need to take forces in the Y and X direction. As I'm recording this the next day as my previous video, I have 0 comments. I did not figure out why that is like that. Oh well, I will figure it out eventually because I'll probably need to. Okay, let's go ahead and take a summation of the X and Y directions. Look, these problems are very much similar, especially these more simplistic ones. This is still a 2D statics problem. Alright, let's go. Some forces up in X, positive X direction. Okay, so it'll be minus CX is the only thing acting in the X direction, meaning CX equals 0. Cool. Okay. Let's go the Y direction. It's the same way. Standard, blah, blah, blah. Positive Y direction equals 0. We get a little bit more here. So we've got our AY, which in the positive direction, minus 15 kilonewtons. Take downward. Minus the 25 kilonewtons from the distributed load. Plus Cy equals 0. Again, we have two variables. How will we solve for it? Like I said, quite simple. Let's take a moment. A moment about A. Now, forgot to mention this last video, but I did say it in a little bubble underneath it. We do not take the forces that are directly on A. So therefore, we're not going to be taking forces of AY at all. Okay, so let's go ahead and take that moment about A. Counterclockwise, positive direction equals 0. Alright, so we've got minus 80 kilonewtons. It's rotating. Minus 15 kilonewtons, which is 5 meters away from A. Minus 25 kilonewtons, which is 7.5 meters away. Plus Cy, which is 10 meters away, equals 0. Giving us the value for Cy is 34.25 kilonewtons. Good deal. Alright, now that we have Cy, let's go ahead and plug in to find AY. Alright, so AY minus 40 plus blah blah blah. Plugging in for Cy equals 575 kilonewtons. Okay, so AY equals 5.75 kilonewtons, giving you your final answer. Alright, good deal, guys. On to the next video.